Now let us continue the session on machine vision. In the previous session, we have seen the concept of machine vision and the elements in a machine vision system. Now let us see in detail about the elements of a machine vision system. We have learned that the machine vision system consists of an image digitizer, there is temporary memory, there is a processor that utilizes filters, and the modified image can be used for three kinds of purposes. Let us see in detail about this. Before we go to the details, I need to tell you about two typical words that are used in machine vision concepts. One is sampling. Sampling means a resolution or the number of pixels available in the sensor area. If this is a sensing area, how many independent sensing units that can be present on a sensing area is called as sampling. Quantization is another word that says about the level of gray that can be processed by the system. That means if each pixel, how many gray levels can be detected by this independently, that depends on the processing capability. I will explain this in the next session with another set of diagram. We are seeing four figures here. We know that this is a vague figure, this is a clear figure. What difference is that here the number of pixels are lower, that is only 128 by 128 pixel, and we know that one pixel can have only one intensity can be produced based on the light falling on that. If the number of pixels increases, naturally the clarity of the image will be enhanced. So this is about 1 megapixel sensor image. This is 128 by 128. So here the sampling, the resolution increases so that image clarity becomes better. Now let us see what is meant by quantization and how it will be affecting in the processing. Quantization, as we have mentioned, it is the capability of a processor. If it's a single bit processor used in the system, one bit, as you know, it can process two information. One bit means 2 raised to 1 is a, that means if it's a binary system, based system, 2 raised to 1 is equal is the number of information that can be processed. In 2 raised to 1 means 2, that means one is a perfect white information, another one is a perfect black information. If the processor is of 2 bits, that means it can process 2 raised to 2 information, that means 4 kind of gray that can be processed. So the image, if you see it, you can see that 1, 2, 3 and white, 4 levels of intensity can be seen this. Like that, 2 raised to 3, if it's a 3-bit processor, 2 raised to 3, that means 8 levels of gray can be seen here. Like that, as the processing capability increases, the levels of gray will be changed. In this, it is a 7-bit processor, there 2 raised to 7 will be the number of information that is developed by the system. 2 raised to 7 is 128. When it comes to 8-bit processor, it is 2 raised to 8, that means 256 levels of gray that is represented here. When you see the figure, this figure and this figure, you can see that we are unable to, we means the human beings are unable to detect there is a difference between these two. That means our processing capability of our brain stops at this level. So generally 8 bits of information per pixel is sufficient if the processing is done by human being. Let us see what are the steps involved in machine vision. Machine vision involves few steps like image acquisition. That means the light that is falling on the sensor will be converted to digital image by means of certain sensors. The image will be processed. That processing means it is enhancement or modification of image, noise removal, etc. Then once the image is developed, after enhancement, the elements in the image will have to be segmented, that is region wise, or the object need to be identified. Then only we can identify an object. Then after getting the different objects, we have to analyze it take measurements of the objects, relationships, etc., so that we can deeply understand what the image is, or we can take information from the image. Again, after this analysis, uh, pattern recognition can be done. That means matching the description with the similar description of known objects or models that is already stored in the memory. The information stored in the memory is one pattern, and that pattern is identified compared with something else. So once the pattern is also identified, we will go for action. That means the system can be utilized for certain action, or it can be stored in the memory, or it can be shown back, as we have seen in the previous session. Now let us see one by one. Image acquisition, that is done by vision sensors. There are many kinds of vision sensors. Here we are seeing that the sensors examples are charge coupled devices, also called as CCD sensor, where the light falling on the sensor will be converted to digital image and that will be stored in the buffer memory. Another kind of sensor is charge injection device, CID chips. Mobile phones with you are utilizing CMOS sensors. So CMOS, this is a view of a CMOS sensor, complementary metal oxide semiconductor. So these are the sensors typically used for converting image to digital image. So next step after we grabbing the image is a processing of the image. Processing means it can be processing, filtering. That means we can filter, smooth the image, filter the image, can stretch and compress, etc. These are all examples of processing, and we get the processed image. I'll give you a few examples of this. See, you see three figures here. This is the original figure, this is another figure, where what happens is a smoothing filter is applied. In certain cases, it is advantageous to blur certain image rather than keeping it crisp image, that we usually practice even in photography. But for certain applications, the blurring will be required. You see another kind of processing here. It's a digital X-ray image of a hand, and you can see that there are many spots here and there. This is an image where this kind of spots, that's a noises, or we call it as a salt and pepper kind of noise, that are removed by a kind of filter. So you get this image. So this is the required image. This was the original image obtained, and you have modified it. In this case, there is an image that is of Earth that is taken by a satellite. Then the image is restored to the required level by applying proper restoration algorithms or processing. This is another image uh, uh, where one information like this kind of patch is very important for further processing. In the previous case, in a medical situation, these dots were not required, so we made it like this. But in this case, this spot is a much needed thing. Say, if it is a cancer on a skin, then that image should not be removed like this. Where in this case, the image should be enhanced for this, so that we can identify the problem on the skin. So depending on the requirement, the noises can be removed. Sometimes the information will be required like this. Sometimes unwanted information will be shown like this. So depending on the requirement, we have to apply various processing. This red eye detection and then healing of image by appropriately fixing surrounding pixel, etc., are examples of image processing. In all these cases, sometimes the image will be made enhanced, or sometimes the image will be modified for the requirement. Now there is a tool that is used in image processing, that's called as histogram. This is a histogram. This is a histogram of this gray image. Histogram means it is a graphical representation of an image by taking the gray levels on the x-axis and the number of pixels having a particular gray level on the y-axis. That means by seeing this, you can say that the levels of gray in this range, the pixels having this gray will be more compared to the pixels having these levels of gray. Say if it is 256 in a 8-bit processor, that means 256 will be representing white and 0 will be representing black. So if that's the case, by seeing the histogram itself, we can identify that more pixels are towards the black range compared to the white range. That means the image is darker. So you can see that this image is more darker in this. There is another example for histogram. See, one scene here, the same scene is shown here. For us, we can very easily understand that this is a better image compared to this. This is a very dark image. So for this image, this is a histogram. It's an almost uniformly distributed, whereas for this image, this is a histogram where the histogram is present towards the left side of the, that means towards the darker side. So if we know the intensity of each pixel and plotted like this, it is also possible for the system to add or subtract certain values to the numerical value of each pixel. And if we add or subtract certain constant value in all the pixels, what happens is the image will be slided, or this histogram will be slided to right or left. That means if it is shifted to right, the meaning is that this number of pixels will be moving to the right. The meaning is the intensity of this level will be more in the figure. In other words, by doing the change, numerical changes in the pixel information, we are actually changing the quality of image. We can enhance or modify the image by processing with histogram. Now another step in machine vision is image segmentation. See, this thing that this kind of rectangular frame shows each pixel. So we know that we can identify this object as a single object only if we identify this as a region. How do we identify by human being, like by sensing that there is a dark part, there is a white part here. Oh, that means all these are darker part, so we believe that all these belonging to a same object. Similarly, in image segmentation, they will classify the pixels into groups based in two different techniques. One is a region segmentation method, where the regions are segmented or identified, regions are identified based on the similarity of gray level. So similar gray level can be identified by seeing the histogram. In this histogram, it's a schematic representation of this schematic object, where we are seeing that there is white, there is gray, there is black. So we know that there are low black region and intermediate number of gray region and more white region. That is very obvious from the diagram. This is region growing, as I have shown you. See, we identify this as an object because when we see that there is similar intensity on this region. Similarly, the similar algorithm is run in automated system also, where similar regions having similar intensity will be grouped together to form one region, and intensity having same will be forming another region, and the other region will be formed by considering the intensity. This is called as merging after identifying the region and growing it. There is one more technique used typically in image segmentation, that is edge detection. We know that when there is an edge, we say that the object stops there. It is possible to identify edge by checking the change in intensity between the adjacent pixels. Say if this is one pixel, this is another pixel, this was the intensity in this pixel and this is the intensity in this pixel. So if there is a drastic change in intensity between adjacent pixel, that means there is an edge. That's a meaning. So if there is a change in intensity, that is called as contrast. Contrast means is the first derivative of brightness. So when you take the image and if you take only the first derivative of intensity, if you get like this, what you get is the edge of the image alone. This is also a modification done so that we can identify that there is an object and this is the edge. This is the edge. To explain this, I'll show you one more example. Here I have a white paper here, other orange paper here, and a white paper here, and it's very easy for us to identify that there is an edge here because there is change in intensity between orange and this white. Whereas it's difficult for us to identify that there is a paper that ends here, there is an edge here, because the change in intensity across these two papers are almost negligible, so we are unable to identify. That means if we identify that there is a change in intensity, that means there is an edge. The same technique is used by the system also to identify an edge. There are other algorithms also to get the edge of an object. This is called as a plus or minus edge tracking method, where the algorithm is such that it will start the sensing of the object by starting from some point, where if the pixel is darker, then it will go, having the same intensity, it will go to one direction. If the intensity changes, say if this is object, so this is the object, and there is no object here. So we know that when it comes here, there is no object, so it will take a left side, that means anti-clockwise movement. If there is an object, it will take clockwise movement. So whenever there is an object, it will take clockwise. If there is no object, it will take anti-clockwise, and it will show like that kind of algorithm is repeated until it goes back to the original position, and thereby it will be detecting that there is an object. Now, image analysis. Analysis means analyzing the image for getting certain information. We can analyze extract information by considering the size, position, orientation, relationship, etc., etc. We can get the information such as velocity velocity and the kind of object, etc. From this analysis. Again, the meaning is extracting information from an object. By seeing this top view of an image, we know that all are rectangular in shape just by seeing the relative position of this rectangle and relative size of the rectangle. Based on our experience, we can analyze the image and we can extract that these are buildings, these can be trucks, these are cars, or this can be a shed, something like that. Okay, again, by seeing such an image like this, it may be possible for us or the automated system to identify at what velocity the object is moving. By analyzing this image, by comparing this image with another image, it's possible, very much possible for the system to identify whether all the electronic components are placed in position in the right way, whether the positioning and the kind of elements placed are correct or not. That means there are many applications for analysis. Only when we analyze it, we can utilize we get information, and we can utilize the information for further steps in image processing. Let us go to the next step of pattern recognition. That means once we identify that there are edges, when we identify that there is an edge, if the object is having a particular shape, we know that this is actually a knife, because we already have the knife image in our memory. So in the automated system also, after identifying the particular region, this particular region will be compared with already known information in the memory, so that it will detect this as a knife. As we detect this as a player, because we know that there is a player, this is the appearance of a player, we know that this is the appearance of a spanner. So when it is a case with the system also, identify the edge of the object, and this, and after segmentation, the system will identify this as a region, and this pattern is compared with another pattern that is stored in the memory, so that this information about the object can be retrieved. By seeing this particular pattern, we can understand that this is a pattern tank that is moving on some surface, and these are examples of pattern recognition. That is, pattern of an object is recognized and compared with a template for interpretation, action, or storage in the library. We have seen this kind of image, or for identifying person, In all these cases, certain pattern will be same, only thing the modification will be there, superficial modification will be there. In the automated system of thumb verification as well as signature verification, it is actually comparing many patterns of many impressions, and that is already stored in the memory, that the information stored in memory is compared with the available information for the further applications. Now let us see in short what are the stages in machine vision. There is first stage is image acquisition, where analog information will be converted to digital information. Another step is image processing, where we are modifying the image by removing noise or improving contrast or whatever we want for the next real applications. Segmentation is the next level, where we will find the regions and objects in the image so that some kind of non-information or non-image will be developed. Then image analysis is the process where the available regions are utilized for taking measurements or relative relationships, etc., etc. And pattern recognition is another step in the machine vision, where we match the description with the similar description so that we can further process it for action. That means the action can be done after pattern recognition. So these are the steps involved in machine vision stages. Now let us have a quick review. Just verify, are you able to answer these questions? You know what is meant by machine vision? Remember, it is not just the vision of human being, it is a vision of living beings are studied in machine vision. Are you able to describe the elements in machine vision system? Are you able to describe the steps involved in the machine vision process? Are you able to distinguish between image quantization and image resolution? Are you able to list few examples for image processing? And are you able to tell what is image histogram? Can you suggest few applications of image analysis? If yes, it's good. Otherwise, please go back and see the content and try to answer these questions. You are strongly recommended to learn from the learning material that is provided in our academic management system. We can post questions and we can have discussion in that location. So we have seen in this entire session of 2 parts. We have seen what is the machine vision, what are the steps involved in the machine vision, and the applications of machine vision. Thank you.